Here's how to write and balance the combustion reactions for two different gases here. Remember, in a combustion reaction, we're always going to have our carbon-based fuel, C2H6O in this case, ethanol. And then we're always going to react with oxygen. It's combustion. It needs oxygen in order to combust. And we're always going to have two products. We're always going to have CO2 and water, which makes it easy to write because we always have the same products. And we always have one of the same reactants. So I have to balance this out now. There's two carbons on the left, so I need two carbons on the right. There's 6 hydrogens on the left, so I need 6 hydrogens on the right. Now the trick is figuring out how many oxygens. It's always this space right here that you're going to do last on a combustion reaction. So here I have 2 sets of 2 oxygen, which is 4. Here I have 3. So there's 7 total. So notice there's 1 oxygen right there. So if I do a 3 here, it gives me 6 oxygens plus 1 equals the 7 on both sides. Okay, so that balances out. This next one is a little bit harder, and we might have to refer back to the notes. Okay, so C5 pentanol, C5 pent 5, right? H12O plus, you guessed it, O2 gives us carbon dioxide and water, like always. When I start balancing this, I'm going to run into a little hiccup, and I'll show you. C5, so there's 5 carbons. I put 5 carbons in there. There's 12 hydrogens, so I make 12 there. And when I go back in to balance my oxygens, notice I get 10 on this side, on this part, and 6 there. That would be 16. There's no combination I'm going to be able to do on this side to give me an even number because I have that number, I have that odd one right there. And so if it doesn't balance out nicely, I'm going to erase all of my coefficients. Get rid of those coefficients. And I'm going to start over. That's what we call CHO times 2, meaning if it doesn't balance nicely, I put a 2 in front of that carbon-based fuel. Now it'll balance perfectly. Okay, so now instead of 5 carbons, I have 10 carbons right there. I have 2 times 12 is 24 hydrogens. So I need a 12 there. And so now I do my oxygens. 2 times 10 is 20 oxygens there. And I have 12 oxygens there. So a total of 32 oxygens that I need. Notice I already have 2 right there. And so I need 30. So I'm going to put a 15 in front of there. And it all balances out. So that's a CHO times 2.